welcome student. We are working on a practical millicon's oil drop experiment, and this is using Amrita, and you should know the procedure of the simulation lab first, because this practical will be done in virtual mode. And in procedure for a simulation lab is, first click on start button, click on combo box to choose the oil, double click on the start button of the stopwatch and notice the time taken T1 by a drop to travel distance L1 between any 2 points. Then click voltage on to suspend the same oil drop in air, which is the balancing voltage V. Click the X-ray on button and notice the time taken T2 by the same drop to travel distance L2 between any 2 points, and charges of the drop is calculated using the equation. Look over here. Q is 6 pi eta r within bracket V1 plus V2 into D by V, and repeat the experiment to another oil. And here is the chart where you will write down your observation. That is clearly mentioned: distance travels L1, time taken T1, distance travel L2, time taken T2, and terminal velocity V1 meter per second, V2 meter per second, balancing potential V, charge of the cloud. I am again repeating the procedure for your simplicity. Here you are using the simulation lab. Procedure for the simulation is click on start button on the simulator lab, click on the combo box to choose the oil, double click on the start button of stopwatch and notice the time taken T1 by a drop to travel distance L1 between any 2 points. Click on voltage on to suspend the same oil drop in air, which is the balancing voltage V. Click on the X-ray on button and notice the time taken T2 by the same drop to travel distance L2 between any 2 points, and charge of the drop is calculated. Q is 6 pi eta R V1 plus V2 D V, and repeat this process using the same procedure and here the observation table. So I think you have learned the procedure of the. Now we are starting the simulation part. This is the simulator. Using this simulator, you can download the simulator app in your smartphone by Puffin software, and you in Puffin software you will just click on vlab.amrita.edu. Then it will show the physical lab. There you will find number of items. You choose millicon's oil drop experiment and start the experiment. Here is the oil drop experiment apparatus. There is a switch button and there is a sprayer and there is a stop clock. Now as per I explained in the procedure session, you start with start button. Then you have chosen any oil. It is the olive oil. There are other is glycerin. Then we have chosen olive oil. Clicking again, you find olive oil. Then voltage. What you will notice the time taken, and then what you will do, just stop it. Then start it. What you will do, you have to find that the time interval between these two fixed point 0 and 0.5. So if you start it, then what will work? It will be first reset. Look over here, resetting it. Then start is the olive oil. Then starting the time. Stop it. Then oil is coming. Then stop. Double clicking, I find the time. So when you press the start button, it is then in the air. Now you see, double clicking it will stop, single clicking it will start. Again I will reset it, start. Now it is stop it, stop, double clicking stop, boil is coming down. Then as soon as the drop is coming down, I will start the time, and when it reach I will stop it. Okay, so now I reset, start, stop the clock, stop. Starting time is 2.9, then the time is, I will start it when it will come, drop will come. Wait until it start coming. Say it started, I am starting the clock. Stop. start. Whenever you do, you just make a double click, otherwise it will not work. Start, then stop, then double click. It started, start, stop. So you notice here that starting and stopping is very important thing. You can note down the time taken, then you press the voltage on, then again stop, the time taken, stop, 4.42. So every time you start and stop, in between two times are calculated. So T2 minus T1 is the time. Then I press X-ray on, going back, then stop. It's going back the position, then stop. 10.29. So you repeat this process various time, practicing that, and you choose again reset, start, change it by another oil, say glycerin. Mm, Glycerin. And bold, it will be stop. Then it is coming down. I will not start it until it. Yes, now I am starting it. It's going down, 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 down. Then stop. It will take 3.32 seconds, right? This way we can measure time. Now, if I doing voltage on, then again time started, reached, then I stop 3.29. So you notice now. Then again X-ray on is going back. First it started, yes, then starting time, start the time. Sorry, I have start at a particular point. X-ray on, then what will work? Reset, start, glycerin, X-ray on, then X-ray on, reset, start, stop, X-ray on, voltage, reset, voltage on, start, then glycerin, voltage on, voltage off, and X-ray on, X-ray on. Then what is coming, and I'm just not doing anything, just return, then I will do. One drop is about to start, then I will click the clock. Yes, now I am clicking the clock, it's going down, down, down. As soon as it reaches the clock, I stop it. So first you start, then you choose a particular oil, then you do the time calculation, then use the voltage on switch, then do the time calculation, then you again use the X-ray on, then you do the time calculation. As I have already mentioned, here oil density is kg per meter cube is 1260. Here we have not applied any voltage. You can use the slider, reset it, start it, choose a particular, say olive oil, voltage on, then using the slider you can set the voltage. First you restart it, olive oil chosen, and voltage on. I am just trying to adjust the slider over here so the voltage can be adjusted. It is showing no voltage. See, I have adjusted the voltage 3.2 kilovolt. Then I am doing the practical. Say reset it. Then start. Olive oil, voltage on. Start. Look over here, the voltage is 3.2 kilovolt. Then you just stop the clock and the voltage is stop. Between the two end, as soon as the ball started from the upper position going down, the time will be calculated. So it is very precious work. As the pot started, the clock is started and the ball reaches the stop it. So 2.39 seconds. Again I am taking it as a reset. Reset, start, then stop the clock. Then again start, ball started, then stop 2.56. So you see, then you use the voltage on, then again stop the clock. Then what will happen? It's coming, then start the clock, and reaches, then stop it. So you note we have done our practical by resetting it, starting it, choosing a particular oil, then without voltage on we are taking a time, then voltage on we are taking a time, then slider and the adjust voltage of choosing a particular value before we start, then we put the X-ray on, and it is going back, and it will be again make a stop, and started the value. I have not started it. When will be another drop will start appearing, I will press it. As soon as it start coming from that position, I will repeat the set, voltage on, choosing the start, X-ray on, stop it, then X-ray on, off, stop, double click, X-ray on, reset, start, stop, X-ray on, going down, X-ray on, ball is coming, start the time, it's coming down, stop. So you know one thing, again you start, so better reset it, then start, then you choose an olive oil, voltage on, extra on, turn the time, start, ball is coming down, and stop 5.57, then X-ray on, ball going to the opposite side, going started, when will be going to this position, and make a double click, again reset, start, voltage on, voltage off, and X-ray on, X-ray on, stop the clock, X-ray on, restart, start, reset, start. Mm. Then start. This ball is coming. Just stop that. 5.25. So it is very, very crucial. You will be adjusting the time very correctly. It is coming very fast. So start and stop button must be pressed very correctly, and time on T1 will be taken, once for voltage on, another for X-ray on. Okay, this is all about the practical. So I am closing it. Thank you for your patience. Here the theory part. Aim is the practical is to experimentally demonstrate the concept of the Millikan's oil drop experiment, to find the terminal velocity of the oil drop, to find the charge on a drop. Apparatus is Millikan's oil drop apparatus. Oil DC supply. Construction is oil drop experiment was performed originally by the American physicist Robert A. Millikan in 1909. It measures the size of the charge on a single electron. Apparatus consists of atomizer which helps to spray tiny droplets. By means of a short focal distance telescope, the droplets can be viewed. There are two plates, one positive and one other negative, above and below the bottom chambers. DC supply is attached to the plates. Some of the oil drop falls through the hole in the upper plates. Using X-ray, the bottom chamber is illuminated, causing the air to ionize. As the droplets traverse through the air, electrons accumulate over the droplet and the negative charge is acquired. With the help of a DC supply, a voltage is applied. Speed of its motion can be controlled by altering the voltage applied on the plates. By adjusting the voltage applied, drop can be suspended in air. Millikan observed one drop after another, varying the velocity, and noticed the effect. After many repetitions, he concluded that charge could assume only certain fixed values. He repeated the experiment for many droplets and confirmed that the charges were all multiples of some fundamental value, and calculated it to be 1.5924 into 17 into 10 to the minus 9 coulomb within 1% of the currently accepted value of 1.602176487 into 40 to 10 to the minus 19 coulomb. He proposed that this was the charge of a single electron. The theory of the work is initially the oil drops are allowed to fall between the plates in the absence of electric field. Due to the gravity, they accelerated fast but gradually slow down because of air resistance. The terminal velocity v1 is repeated by v1 is L I1 by L1, and L1 is the distance traveled in the oil drop. T is the time taken. Then similarly, the drag force acting upon the drop is calculated by another formula, Fb 6 pi eta R1, and because of the apparent weight, true weight minus of the thrust for a perfectly spherical body, the equation is Fg is 4 by 3 pi r cube into g into rho minus rho air. Then the at terminal velocity, the oil drop is not accelerating, and so the total force acting on them must be 0. Therefore, Fb minus Fg is equal to 0, and Fb is equal to Fg, and we get r square is 9 eta v1 by 2g rho minus rho air. Then where r is radius of the oil, eta is the viscosity of the air, p is terminal velocity, g is the acceleration due to gravity, and 9.8 meter per second square, and rho is the density of the liquid, it is fixed. Rho air is density of the air, it is also fixed. Now a field is proposed in the bottom chamber with the supply voltage A. Likely looking drop is selected and kept in the middle of the field of view by adjusting the voltage. If the electric forces F is balances the gravitation force Fg, then the drop suspended in the air. Then finally you get Fg is equal to Fe is Qe is mg, or Qb by g is equal to mg. Therefore, the V is the balancing potential and D is the distance between the plates, and if the plate voltage electric force is AP is generated, then downwards the forces sum of the drop. The charge 1 will start to rise. Now the electric force will act upwards, gravity and viscous force acts downwards. Corresponding terminal velocity V2 is calculated as V2 is L2 by T2, where L2 is the distance doubled by the oil drop in time T2 seconds, and now the total force acting on is drop Fe minus F dash B minus F is equal to 0, or F is F dash B plus Fg. F dash B the new viscous force under the action of electric field, thus Q is 6 pi eta R V2 plus 6 pi eta R1, therefore QB by D is 6 pi eta R V1 plus V2, and here we find Q is 6 pi eta R V1 plus V2 D by V. Millikan repeated the experiment number of times, each time varying the strength of X-rays ionizing the air. As a result, the number of electrons attaching to the oil drop varied. Then he obtained various values of Q1 and is found to be multiple of 1.6 and 10 to the minus 19 coulomb. That is all for your theory, procedure and simulation lab. Thank you for your listening.